Hello, and welcome to Aggressive Physics. Today is day 139, and what we're going to do today is continue our review of the course. Specifically, what I'd like to look at today is circular motion, momentum, and impulse. And what we're going to do is another practice set of problems dealing with circular motion, momentum, and impulse. And hopefully at this point you've already done this assignment, and we're going to compare it to the solutions that I'm about to do on the whiteboard. So let's take out the whiteboard now and solve problems dealing with circular motion, momentum, and impulse. Thank you. All right, on to review assignment 3. Question 1. We have a car that is 2 times 10 to the 3 kilograms, and it's moving at 12 meters per second around a radius of 30 meters. So RVM, what's the centripetal acceleration? That's V squared over R. 12 squared over 30. So 12 squared divided by 30 is 4.8 meters per second squared. Choice 2. Now we have a lump of clay colliding with a block. So this is going to be a collision, and it's going to be a conservation of momentum. So P1 plus P2 equals P total is number 2. So the clay is 1 times 6 mv, 0 for the block, and the total mass is going to be 4 kilograms times v. So 6 divided by 4 is 1.5 meters per second. Choice 1. Question 3. We have an object moving counterclockwise, and at the point it's shown, so it's moving this way, what is the direction of the centripetal acceleration, which is inward, and the velocity, which is tangent? So V and A. And since we're talking about centripetal force, that's also the direction of the force. So inward and up, choice 2. All right, 4. What represents the relationship between the centripetal acceleration and the speed of an object moving in a circle of constant radius? So A is V squared over R. If we have constant radius, A is direct squared related to V. So which one shows direct square? Curve that looks like that. So that's going to be choice 2. And then number 5, we have 2 carts colliding. We have one going east. It's 20 kilograms. It's going at 6 meters per second. The other one is going west, and it's 30 kilograms. What's the speed if they stop afterwards? So momentum 1 plus momentum 2 equals 0 because they stop. 20 times 6 plus 30 times V equals 0. So 20 times 6 is 120 divided by 30. V is 4 meters per second. And of course, it was going to the west, so it would be negative, but we're looking at speed. So choice 4. All right, number 6. We have a bucket being swung in a horizontal circle of radius 0.7. What's the magnitude of the centripetal force? Well, the equation is mv squared over r, 5, 2 squared over 0.7. So 5 times 4 divided by 0.7 is 28.6. So 28.6 newtons. which the closest one is 3, 29. All right, 7. All right, we have a point on a car rotating at a constant rate. What's the magnitude of the centripetal acceleration as a function of time? Well, centripetal acceleration is constant. So the only one that shows a constant centripetal acceleration is 2. All right, now 8. We have a car colliding with a tree and brought to rest. What's the impulse? J is F delta T equals M delta V, also known as MAV fat. Now we have the force and we have the time, so we're just going to use those two. 6 times 10 to the 4 times 0.5. 6e4 times 0.5 is 3 times 10 to the 4 Newton seconds. Choice 2. All right, question 9. A 3.1 kilogram gun initially at rest is free to move. A 0.5 kilogram bullet leaves the gun with a speed of 500 meters per second. What's the speed of the gun? So there's conservation of momentum. P total equals P1 plus P2. Total P is 0 to start. 3.1 kilograms for the gun times V plus 0.015 kilograms times 500. So 0.015 times 500, 7.5, divided by 3.1 is 2.4 meters per second. Choice 2. All right, 10. All right, we have a problem with no numbers. Also conservation of momentum, so P1 plus P2 equals, it embeds itself, so P total. So mv, small mv, plus 0, because it's stationary, equals little m plus big M, the total mass, times v prime. And we're looking for v prime. So v prime equals mv over m plus big M. All right, mv, oh, they're pulling out a v, so it's going to be choice 4. They wrote it as m over m plus big M times v. We're just factoring the v out. Now 11. We have acceleration. It's moving in a horizontal circular path. So we're going to do centripetal acceleration, v squared over r. So we have 4 meters per second squared over 0.25 meters. 16 divided by 0.25 is 64 meters per second squared. Choice 4. All right, 12. We have a cart traveling at a constant speed and a radius of 3. Centripetal force is 24 newtons. What's the acceleration of the cart? Well, we know the force is 24. We're going to do F equals ma. 24 newtons equals m, which is 2, times a. So a is 12. And, oh, I see, we're looking at different directions. It's always inward, so it's point D, which is choice 4. 13. Go-karts traveling around a flat horizontal circular track. Okay. What is the maximum speed the cart can go without sliding? All right. Magnitude of the maximum force is 1,200 newtons, it says. So F equals mv squared over r, 1,200. Mass is 200. V squared over 25. We solve for V. 1,200 times 25 divided by 200, and the square root, 12.25. So closest number, so 12.25, which is 2. All right, 14. We have a momentum. We have a force of the catcher's glove on a ball. Okay, so I'm going to think it's going to be a MAV fat problem. We have 0.149 kilograms. It's going at 15 and then brought to rest, so that's 15. F, 0.04 seconds. Solve for F. 0.149 times 15 divided by 0.04, 55.9 newtons, which is closest to 56, choice 4. And 15, we're in a circle again, so it's centripetal, mv squared over r, 0.5 kilograms, 2 squared, radius is 1. So 0.5 times 2 squared is 2. Choice 2. All right, 16. We have a cart moving to the right and a cart moving to the left. When the carts collide, they lock together, total momentum. So, conservation momentum says the total momentum before and after a collision is equal. So, momentum before equals momentum after. So, we have 4 and 3. So, this is 4 and 3. This is 3 and 6. So 4 and 3 is 12 positive. 6 times 3 is 18 negative. So the momentum is negative 6 kilogram meter over second. So that never changes. So 2. 17. We have another catcher's mitt problem. MAVFAT. 0.15 kilograms times 20 meters per second is a lot faster. F, 0.01 seconds. What's the force? 0.15 times 20 divided by 0.01, 300 newtons. Now, they're all in threes, so it's scientific notation. 1, 2, 3 times 10 to the 2 newtons. Choice 4. Now, 18. Force of 6 newtons changes the momentum by 3 kilogram meters per second. So that's J equals F delta T. J is 3 kilogram meter over second. 6 newtons times T. Well, 3 divided by 6 is a half. Half a second. And that's choice 4. All right, number 19. We have an object in a circle. We want to find the centripetal force. So that's going to be mv squared over r. It's a 1 kilogram object. It's moving at 5 meters per second, and that's squared, over the radius of 0.5 meters. So 1 times 5 squared divided by 0.5, we get 50 newtons. Choice 4. All right, number 20. We have an object with a momentum strikes an obstacle. The obstacle exerts an impulse of 10 to the west. So, impulse, J is 10 newton seconds. Momentum of 30 kilogram meter per second. So we already have 30 kilogram meter per second, and it's going to be 10 to the other direction. So it starts with a momentum of 30, It loses 10, so the momentum after is 20. And it is a 6 kilogram block, and we want to find out what the new speed is. Okay, 20 divided by 6, which is 3.33 meters per second. Choice 2. And 21. We have an object that is moving to the right, to east. So we have momentum is mv. It's 2 times 40. So it starts at 80. Constant force is applied to the east for 5 seconds. So the impulse is going to be 10 times 5, force times time, so 50. So 80 and 50, because they're both going to the right, so it's going to help. 130 Newton seconds equals mv. So it's a 2 kilogram object. So the v is going to be 130 divided by 2, or 65 meters per second. Choice 3. 22. We have a mass traveling in a circle. What's the centripetal acceleration? So the equation is v squared over r. All right, we know it's 2 meters per second. The radius is 0.2. So 2 squared over 0.2. 2 squared divided by 0.2 is 20. Choice 2. 23. All right, we have another problem with no numbers. So we have an object moving MAV plus 0, and they stick together, so then you're going to have MA plus MB times V prime. We want to solve for V prime, so it's going to be MAV over MA plus MB. Divide by that term. So MAV over MA plus MB. That's choice 4. And 24. We have a hockey player skating across the ice at a speed of 6. What's the average force to stop him? MAV, fat. 75 times 6, F, 0.65 seconds. 75 times 6 divided by 0.65 is 692.3 newtons. And the closest one is 690, choice 3. All right. All right, 25. What's the speed of a kilogram, 1 times 10 to the 3 kilogram car with a momentum of 2 times 10 to the 4? So we know P equals mv. So 2 times 10 to the 4 is the momentum. 1 times 10 to the 3 is the mass. And we want to find v. 2e4 divided by 1e3, 20 meters per second. Now, of course, they write in scientific notation, so that's going to be choice 2. 2 times 10 to the 1. 26. All right, we have the same picture we had before. We want to know the speed of the cart. So we have the force, and we know the radius and the mass, so it's mv squared over r. 24 equals 2 v squared over 3. So 24 times 3, cross multiply, divided by 2, square root, 6 meters per second, which is choice 1. 27. We have a constant force to stop a cart. So we're looking at MAV, fat. It's 2.5 kilograms. We stop from 20 to 0, so the change in velocity is 20. 10 newtons, 5 seconds. Wait a second. We know everything. Aha, but we're looking for the impulse, and all of these equal j. So we could solve for either side, and let's make sure they're the same. 2.5 times 20 is 50, and 10 times 5 is 50. So 50 is the impulse, and that's Newton seconds, and it's choice 3. And 28. We have a bullet fired from a rifle by an unbalanced force of 200 newtons. What's the maximum speed? So we have MAV-FAT again. So 0.025. Velocity is what we're looking for. Okay. Force is 200, and time is 0.1. So 200 times 0.1 divided by 0.025, and you get 800 meters per second. Quite fast. 4, choice 4. All right, 29. 2 kilogram ball traveling north collides head-on with a 1 kilogram ball traveling south. What's the total momentum after collision? So we have a north, which is 2 times 4, which is 8. And we have a south, which is 1 times 8, which is 8. A north, which is a plus, and a south, which is a minus, is 0. So before the collision, it's 0, and after the collision, it's 0. So choice 1. All right, 30. What's the greatest change in momentum? All right, accelerating from rest to 3 meters per second, accelerating from 2 to 4, a net force of 5 for 2, or a net force of 10 for 5. All right. If we have it from rest to 3 meters per second, and we have the same mass for everything, so let's just call mass 1. So 1 times 3 is 3. Accelerating from 2 to 4, so 1 times 2 is 2. Net force for 2 seconds. So now we're doing the F delta T. So these are MVs. Now we have an FT. 5 times 2 is 10. And then we have a 10 times 0.5, also an FT, which is 5. So biggest change is going to be 3. Remember, change in momentum is also known as impulse, and we can use any version of the impulse equation to calculate it. All right, we have a spring holding blocks together, and we're going to have motion to the right and left. So this is conservation momentum. P total equals P1 plus P2, 0 before they start. The 1.8 moves at 2, and the 1.2 moves at, I don't know, let's find out. 1.8 times 2 divided by 1.2, and that's going to be 3 meters per second. Choice 3. All right, and finally for this page, 32, what's the impulse on the 30 kilogram roller skater? So we have a mass, we have a force, and we have a time. So J is F delta T. 10 times 0.2. 10 times 0.2 is 2. 2 Newton seconds. Choice 2. Look at that, 2s are wild. 33. All right, we have a football traveling and is caught by a stationary receiver. The football comes to rest, the magnitude of the impulse. All right. So it's brought to rest. So we know the impulse is going to be m delta v. The football is 0.45, and the speed starts at 22 and ends at 0. So the change is 22. Anytime we have a change in momentum, that's also known as impulse. So we get 9.9 Newton-second impulse, which is choice 2. 34. At the circus, a 100-kilogram clown is fired at 15 meters per second from a 500-kilogram cannon. So we have a cannon, we have an object in the cannon, and then we have the cannon, and we have the object out of the cannon, and it's going to recoil. So before it's 0 momentum equals P plus P. So 1, 2, and 0 equals. We have 500 for the cannon times I don't know, plus 100 times 15. So we're going to do 100 times 15. We're going to divide it by 500. And we're going to get the cannon recoil at 3 meters per second. Choice 3. And finally, 35. Bullet is traveling and brought to rest by an impulse of 50 Newton seconds. What is the mass? So J is the impulse. M delta V. 50 equals M 5 times 10 to the 2. And we do 50 divided by 5e2. And we get 0.1. 0.1 kilograms. Now, of course, everything's in scientific notation, so choice 3. 1 times 10 to the negative 1 kilograms. And that's it.